Good morning to all. Uh, I hope all are well. Already I have taken many classes on operational amplifier, uh, and I have done introduction to operational amplifier. Then I discussed the specifications of the parameters that are associated with operational amplifier. Then one by one, I started with the applications of operational amplifier. That is, I did inverting amplifier, non-inverting amplifier, then subtractor, then not subtractor, differentiator, then integrator. So all these are applications. So today I'm going to deal with the one more application that I call as a subtractor or the difference amplifier. So it is going to find out the difference of the two inputs, or it is going to perform the subtraction operation. That is, as we are doing C is equal to A minus B. Okay, so here V naught is equal to V2 minus V1. So it is performing the subtraction operation. So already we have derived many equations, or we have seen many applications of operational amplifier. We have either applied the input to the inverting terminal, or we have applied the input to the non-inverting terminal, and we have obtained the output at the output terminal. Correct. Now in this application, we are applying one input to the inverting terminal of an operational amplifier and the second input to the non-inverting terminal of the operational amplifier. Okay. Then I am getting the output at the output terminal. Now here the derivation for the output is completely different from the derivation for the previous applications. So first, there are two steps here, or the two cases. In first case, the second input I am grounding, and first I am getting the output only due to the V1. Okay, that is, I'm first calculating what is the output due to the application of V1 when I'm grounding V2. That is, V2 I'm not applying. Okay, only V1 I'm applying, and I'm finding out what is the output that I'm getting. Second case, V1 is grounded, and I'm getting the output only due to V2. Then at the end, I'm combining both the cases and obtaining the output for both the inputs. Okay. So here I am taking, let VO1 or VO1 be the output with the input V1 acting alone. Assume V2 to be 0. Okay. So VO1 is the output with the V1 acting alone. Okay. Then VO2 the output with the input V2 acting alone. Okay. Assuming V1 to be 0. So VO1 is the output due to only V1. VO2 the output only due to V2. Okay. So these two cases we will study. Then we will add the output due to V1 and V2. Okay. Output due to V1 and V2. So that we call as a total output. Total output V0. Okay. So that this is the way we are going to analyze this subtractor. Now you just see here, I have taken the first case. So what is the first case? I am applying V1 and finding out the output only due to V1. So V2 is grounded here. So you just see the circuit diagram. You just analyze the circuit diagram. You just compare this circuit diagram with the previous applications. So when you compare this one, this circuit looks like an inverting amplifier. So the output due to inverting amplifier, already we have equation, that is V0 is equal to minus Rf divided by R1 into V1. Okay, so here V1 is missing. So while taking down the notes, you just write V1 here. Okay, V1 is missing here. Then next, so VO1 is equal to, so here VO1 is equal to minus RF divided by R1 into VN. So here the VO1 is equal to minus RF by R1 into VN. So VN is missing here. We'll just write out VN. Okay, next, I'll take the case 2. I'll take the case 2. In this case 2, I am applying V2 to the non-inverting terminal of an operational amplifier. Okay, a non-inverting amplifier, and V1 is grounded. V1 is grounded. Now, you just see the circuit diagram. When the input is applied to non-inverting terminal, and this is the circuit diagram. This circuit diagram looks like non-inverting amplifier, which is going to amplify the voltage at point B, node B. Okay, so voltage, this is the node B and this is node A. So voltage at node B. So now next step is we need to find out what is the voltage at node B. So how we have to find out? So voltage at node B. So voltage at node B is due to available due to the application of V2 at this point. So how we are going to find out the voltage at this point? So voltage at this point can be obtained by voltage divider rule. Voltage divider rule. So voltage at node B and denoting by VB. Okay. So VB is equal to RF divided by R2 plus RF into V2. Okay. So V02 is equal to 1 plus RF divided by R1 into VB. That is out. So here voltage is VB, and this particular circuit acts as a non-inverting amplifier which amplifies the voltage which is available at this point. Okay, so what is VB? So VB is obtained using this equation. VB is RF divided by R2 plus RF into V2. Okay, so the will substitute the equation for VB in this equation. Then I obtain 1 plus RF by R1 into RF divided by R2 plus RF into V2. Okay, so this is the output. This is the output due to V1 and this is the output due to V2. Okay, now here I will apply superposition principle, that is output that is available due to V1 and V2 is equal to the sum of the output due to V1 only and output due to V2 only. So this is called a superposition theorem. So total voltage is equal to V01 plus V02. So what is V01? V01 is minus RF by R1 into V1. Okay, so that is here, this one. Then plus 1 plus RF divided by R1 into RF divided by R2 plus RF into V2. Okay, so this is the total voltage that is available. This is the total voltage available at V0 at the output terminal of operational amplifier due to the application of V1 and V2. Okay, so if I take R1, all resistance equal, for example, R1 equal to 1 kilo ohm, R2 is equal to 1 kilo ohm, RF is equal to 1 kilo ohm, and this RF is equal to 1 kilo ohm, I will get V0 is equal to V2 minus V1. Okay, so once you write down all these equations on the notebook, uh, according to me, you will come across uh, some of the doubts. Okay, so I will clarify all the doubts. If you have if you text me in the WhatsApp group or if you call me, okay, in the next video. So please go through the videos and go through the PPTs that I have given. Please go through the notes that I have given, and we keep studying this basic electronics.